So we're going to do the calculations to determine the number of risers, number of treads, unit rise, unit run, and total run for our demonstration stair. We've determined that our total finished rise is 37 7/8. The first step we want to do is find the quantity of risers. So we're going to take our total finished rise and we're going to divide that by the maximum rise that we're allowed to have by code. So that maximum rise is 7 3/4. So we're going to type in our total rise, 37 inches and 7/8, and we're going to divide by 7 inch and 3/4, which is our maximum rise allowable. Our answer is 4.88 risers. Now, we can't have a decimal amount of risers. We have to have a whole number of risers. So we're going to round up to 5 risers. Our treads will always be one less than the number of risers. So in this example, we have 4 treads. Now we're ready to calculate our unit rise. We have our total finished rise and we have the quantity of risers. So now we just need to take our finished rise and divide by our quantity. 37 inches and 7/8 is our total rise divided by our number of risers, 5, equals 7 9/16. So our unit rise is 7 9/16. Our unit run, assuming it's a residential stair, is 10 inches for simplicity and to keep the stairs as small and short as possible. There may be times when we want to use a dimension other than 10 inches, but unless otherwise instructed by the architect, 10 inches is our preferred unit run. Our total run is then a factor of our unit run and our number of treads. It is simply quantity times the length of the unit run. So 4 times 10 inches is 40 inches. Now we're ready to calculate our stringer length. As you can see from our drawing here, our stair is a Pythagorean triangle. We have our bottom leg of our triangle, we have our top leg of our triangle, and we have our hypotenuse, or our diagonal of our triangle. The reason we include our phantom run is to complete our triangle. If we were to just use our total run, our triangle would not be accurate to how we build and lay out our stair. So we will include an additional 10 inches, which is 1 unit run for our phantom run when we calculate our diagonal for our stringer. We also know that this distance, the height, is 37 7/8 inches. That's our total finished rise. So when we type that into our calculator, will look like so. We'll take our total finished rise, 37 inches and 7/8, and we'll tell our calculator that it's our rise. And then we'll type in our total run plus our phantom run. We can do that mathematically. We can add it. 40 inches plus our phantom run of 10 inches equals 50 inches. And then tell our calculator that is our run. Now all we have to do is ask the calculator what our diagonal is. In this case, our diagonal is 62 3/4 of an inch. That is our stringer length, 62 3/4. So in preparation for laying out our stringer is this piece right here. That is the main framing component of our stair. So that is the stringer that we need to cut. To accurately cut that stringer, we will need to find the pitch length of 1 unit rise and 1 unit run. To do that, we can simply take our stringer length and divide by our number of risers. As you can see here, we have a line segment that if we divide by 1, 2, 3, 4, 5 segments, will give us 5 equal segments of that pitch length. So 62 inches and 3/4 is our stringer length, divided by our number of risers gives us a pitch length of 12 and 9/16 inches. So that is 1 pitch length for 1 tread and riser. So now that we have our pitch length, we want to make a list of increments starting from the top of our stringer at the very top of the stairs, and a list of distances for each of the successive pitch lengths. Now, we may be able to simply multiply 12 and 9/16 times 2 for the second one times 3 for the third one. But the most accurate way to do this with our calculator is to make sure that we calculate our stringer length, 62 inches and 3/4, divided by 5 for our pitch length. And when it's fresh in our calculator, the calculator has internal memory that takes this decimal to several places beyond what is displayed on the display. The reason that's an advantage is it eliminates rounding error. If we were to do the basic math without the calculator, eventually if there's a rounding error in this 9/16 of an inch, we would slowly creep away from the total stringer length. But because this calculator has that information embedded into it, we can simply add itself, so hit the plus and the equal sign, and it takes that 12 and 9/16 and whatever rounding it's not displaying and adds it for the second mark. So the second pitch length would be 25 and 1/8. So thus far we have 2 marks for our pitch marks. We have our first one, which is 12 and 9/16, and we have our second, which is 25 and 1/8. If we hit the equal sign again, we get our third mark, and it's sequentially adding 12 and 9/16 to the previous. So 37 and 5/8. Notice that the difference between these two numbers is not 12 and 9/16, it's actually 12 and 1/2. That's the rounding error I was mentioning in the internal memory of the calculator. So it's slightly adjusting as we go down the stringer. We hit the equals button again, we get the next pitch mark at 50 and 3/16. We hit it again and we get 62 and 3/4, which we know is our stringer length and also the final mark on our layout. So here's an illustration of our pitch marks from the top of the stair. The first pitch mark at our 12 and 9/16, the second mark at 25 and 1/8, the third mark at 37 and 5/8, the fourth at 50 and 3/16, and the last, which is our stringer length, at 62 3/4.